As in the previous video, we discussed the joint distribution of the rth order statistic and sth order statistic, for which we defined this line array, the event E, as this line array, and the event E says that r minus 1 values of xi are less than or equal to x, for which this is the probability. One value lies between x and x plus dx, for which this is the probability. So it appears as if it follows multinomial distribution. So we used multinomial distribution to explain the PDF. One thing you should remember here is the fact that limit delta x tends to 0, y of x plus delta x minus y of x divided by delta x. What is the meaning? The value of y at x plus delta x minus the value of y at x when it is divided by delta x. When delta x is a very small quantity, the answer that you get is nothing but dy by dx. Okay, so that is what we have used here. F of x plus delta x minus f of x divided by delta x. As delta x tends to 0, it is nothing but dy by dx means what? Y dash of x. Similarly, this is f dash of x. But what is f dash of x? It is f of x. Okay, so this is how we derived the joint distribution of rth order statistic and the sth order statistic. Now let us consider the joint distribution of, see, previously we considered the joint distribution of two order statistics, XR and XS. Now we are going to consider the joint distribution of k order statistics. Okay, it is not kth order, try to understand, it is k order statistics. So I am going to take k order statistics now, k numbers of order statistics, the first order statistic, the second order statistic, which I am going to consider. Like this, I am considering k variables. I want the joint distribution of all these k variables, okay, for which again I am considering this line array, and I assume that my xr1 lies between x1 and x1 plus delta x1. Okay, and suppose that here I have xr2 which lies between x2 and x2 plus delta x2. Okay, and let us suppose that I have xr3 here which lies between x3 and x3 plus delta x3, and let us assume that it is my xrk, right, xk and xk plus delta xk. Okay, right. Now here I have only one value. I assume that this interval is very small so that it accommodates only one value, and this interval is also very small and it accommodates only one value. Again for this interval also, right? That is my assumption. So up to this r minus 1, r1 values are there, and only one value is in this interval, which means that r1 minus 1 values are in this interval, and also up to this you can say you have r1 values. Okay, right, and see, up to this you have r2 values, right, and let us have one more discussion. Up to this you have r2 minus 1 values. Okay, so how many values will be here? r2 minus 1. See, up to this you have r2 minus 1, and from this, see, up to this you have r2 minus 1 values, minus you should reduce r1 values. Okay, this is the logic, right? So here just let us go for a guess. Up to this we have r3 values, right, and up to this, from here to here we have r3 minus 1 value, and up to this you have r2 values, that is reduced. Okay, fine. Now directly we shall write the joint CDF. Okay, now the joint distribution. We are writing joint CDF. Try to remember that, okay? N factorial by this interval r1 minus 1 factorial, then this interval 1 value, and in this interval we have r2 minus 1 minus r1 values, and here we have 1 value, and here we have r3 minus 1 minus r2 values, right? It goes like this, and at the end how many values are there? N minus rk, right? N minus rk factorial. Okay, let us come to this. What is the probability that a number lies in this interval? It is f of x1 power r1 minus 1 into. In this small interval you are going to consider, and you will let delta x1 tends to 0. So you are going to get f of x1 here. I am writing directly. Okay. In this interval you have, let me write f of x2 minus f of x1. Is it right? F of x2 minus f of, what happened to delta x1? It has become 0. Okay. x1 power r2 minus 1 minus r1. In this interval, in the next interval, you are going to get f of x2. Okay. And in this interval, you are going to get f of x3 minus f of x2, the whole power r3 minus 1 minus r2. Let me continue here. Okay. Into what is this? F of x3. And it goes like this. And at the end I will have f of xk. And what about this term? Up to this is xn. Okay. This is actually xn. So up to this the probability is 1 minus f of xk, the whole power n minus rk. Okay. So you can write it directly instead of deriving, because you had a good understanding of its derivation in the previous one. Okay. Right. Now let us go to the next question. How to derive the joint distribution of all, here I mean all, okay, all the n order statistics. For all the n order statistics, see, f of x comma y is the joint distribution of x and y. F of x comma y comma z, f of x, y, z, m. Okay, so if you have 3 or 4 or 5 variables, you can make use of this k order statistics. In general, we have derived it for k. Okay, now we want to have it for all the n order statistics, because every order statistic is a random variable. So what are the variables under consideration? First order statistic, second order statistic, and this is the last order statistic. What is the joint distribution of all these? That is what we wish to know, right? See how I am getting this. This is my first order statistic. My second order statistic lies somewhere here, and it goes like this. And I have the nth order statistic here, right? So here I have x1 plus delta x1. The interval, assume that it is so small that only one value can be accommodated. Okay, that is your that is what you should understand, right? To make you understand, I'm making the interval big, but that is not so. This is a very small interval where only one value can be accommodated. Okay. Listen carefully. See, this is the first value. So how many values will be before this? Nothing. And after the second value is here. So how many values will be there in this interval? Nothing. Okay. So you go like this. Now how many values? N values are over here. How many values will be after this? Nothing. Right. So let us write the joint distribution. So the joint distribution is n factorial by, see here one value, here one value, 0 factorial, 1 factorial, 0 factorial, 1 factorial. It goes like that, and at the end you have 0 factorial, 1 factorial. Okay, And what is this actually? F of x1, f of x1. And what is this? F of x2. And it goes, here you have nothing. Even if you write, for example, if you write f of x2 minus f of x1, how many values are there? The whole power 0. It is going to become 1. Okay, that's why I didn't write all those things. So you get f of xn. So what is your answer? N factorial into f of x1 into f of x2, etc. f of xn is the joint distribution of all the n order statistics. Okay, thank you.